Hello everyone, I'm Anuruddha Liyanarachchi. Thank you for joining my session on Simplify Network Services for Real-World Cloud-Native Applications with Ballerina. Without further ado, let's dive in. Ballerina, at its core, is an open-source cloud-native programming language designed to make integration a breeze. It is a product of a dedication nurtured by the folks at WSO2 since 2016, and it officially released in February 2022. And that's not all. Ballerina comes with a vibrant ecosystem offering a plethora of network protocols, data formats, and connectors. What's exciting is that you can craft your code the way you like it, whether through text or visually using a sequence diagram, flowcharts for that added quality. Ballerina brings in built-in user-friendly and user-efficient concurrency, all backed up with safety features, ensuring your development journey is smooth and secure. In modern programming, everything is an endpoint. Say it be a database, a security handling, or even an Internet of Things Android device, everything can be an endpoint. Interesting thing is that the application that we are building or cloud native apps are increasingly depending on these endpoints. So effectively what we are building is an application which is talking of the network with a massive number of endpoints. So integration is the discipline of resilient communication between endpoints. It isn't easy. You know that there are a lot of technology and techniques have designed to help build systems like compensations, transaction, events, circuit breakers, discovery, protocol handling, and mediation. These are all hard problems to solve. In the past, we had two ways of solving this. Left hand side, we have used and using systems like ESBs, EAIs, or Enterprise Service Bus, or Enterprise Integrations, Business Process Management to solve this problem. These things are understand integration. It helps to do integration simple. And they have one big challenge, and that is it is not agile. In other hand, you can use general programming like Java, Node, and the challenge of these, they don't understand the integration. They are not integration simple. So developer has to take responsibility for either solving hard problem or they have to find a suitable framework to support that. Camel and Spring integration frameworks are some common framework people are using. These are complex bolt-on framework and don't necessarily be integration simple and still have high learning curve and complexity. So we kind of came to a conclusion that we call it integration gap, which is you can either be agile but not integration simple or integration simple but not agile. As an integration company, WSO2, we have been working for more than a decade to solve these integration problems. And we have been working on more than 1,000 integration projects, and almost every project ends up in one side of that integration gap. Now let's see how Ballerina is minimizing this integration gap. The Ballerina is a cloud native language. So how it is cloud native language? The language network primitives simplify writing services and deploying them in cloud native environments. These primitives make it easier to handle network related tasks, which is crucial for cloud native application development. Ballerina is a flexibly typed language. So structural types with support for openness are a key feature in Ballerina. They serve two purposes. One enables static typing and two describing service interfaces. This flexibility is valuable for designing and maintaining complex systems. Ballerina allows for type-safe declarative processing of various data formats, including JSON and XML and tabular data. So thus making the data processing over network much simpler. So language integrated queries simplify data manipulation, enhancing productivity and code quality. Ballerina programs offer both textual and graphical representations. The graphical form based on sequence diagrams provide a visual way to understand and design program flows. Also, it makes your code documentation much simpler. Ballerina excels in providing easy and efficient concurrency management. The use of sequence diagrams and language managed threads simplifies concurrent programming without the complexities often associated with asynchronous functions. Ballerina also enhances program reliability and maintainability to several means. Explicit error handling, static typing, and concurrency safety contribute to most robust applications you can develop. This is all achieved while maintaining a familiar and readable syntax, making it easier for developers to work and understand the code base. Let's see Ballerina in action. When it comes to Ballerina, the preferred IDE plugin is Visual Studio Code. It also offers support for various IDE plugins for Visual Studio Code, such as Docker, Kubernetes, OpenTelemetry, Choreo, Copilot, and GitHub. Recently, we have added support for Azure Function as a Service deployment as well. So when you are using VS Code, everything will be for you. Everything that you need to compile, debug, run, observe, and monitor your application will be with Visual Studio Code. So as I mentioned, Ballerina is a graphical programming language as well as syntax programming language. So this is a sample of what Ballerina looks like in Visual Studio Code. You have a simple program with the main function, and on the left side you can view the code. On the right side you can see the sequence diagram that simplifies what this code does. So what this code does is actually it connect to the GitHub API and then get the open pull request, and then using the Google Sheet connector, it add those connected pull requests to the Google Sheet. So you can simply check this sequence diagram and understand the code better. You can also edit the sequence diagrams to generate code as well. It works both ways. Similar to the previous slide, which shows a sequential program, it also works with an integration designer as well. This is a sample Ballerina service, a REST service that we have run, HTTP service. So it also displays the service, the types that it has declared, and you can also view the Open API configurations of this service as well. You can navigate to the sequence diagram view, and then in that view you can also view the Open API of the service that you write as well. So VS Code also support auto completion of Ballerina program codes. It also knows the libraries that Ballerina has. So we have a set of standard libraries for doing the standard functionalities of a programming language. So those functions will be simply, you can add it, simply export it, and you can just use them in your IDE. The IDE will automatically complete the values there for you. Ballerina has also cracked the challenge of mapping one kind of data into another kind of data, which is a common scenario in integration. You can do that in code as well as our graphical editor, as shown in this picture. So it is very easy. When you do the graphical one, you can just add a functions to convert value from one end to another value. Ballerina also support data persistence. So when you write a code or declare your objects, or use in Ballerina, those are called records. When you declare your records, Ballerina will automatically map the entity and relation stream diagram between them. You can simply generate the SQL code that you want to execute to run this Ballerina program. So that also works graphically as well as textually. Ballerina also supports debugging your application via VS Code. You can remote debug your application and check the values that you receive for your inputs and check your logics in the debug mode. Simply add debug pointers to the code and start the application in debug mode. If you are using multiple services in your application, you can picture or graphically view them using the architecture view of the VS Code plugin, Ballerina VS Code plugin. So this is a complex system that handles multiple services. You can simply go to the architecture view to see the connections between those services, and you can drill down on each component and see fine details as well. Ballerina has inbuilt support for multiple tools that is required essential in integration. So one is the Open API tool, which generates a client and skeleton for the Open API specification that you receive. GraphQL tool, which generates client skeletons in Ballerina for your GraphQL endpoints. Async API tool, which generates Ballerina service and listener skeletons for an async API contract. And strand and dump tool, which dumps and inspects current available strands of a Ballerina program, which is used for performance testing. Then health tool, which generate FHIR HL7 profile to client and stub generating tool of Ballerina. We also have support EDI tool, the set of command tools that provide to work with EDI files in Ballerina. This is just most used tools. There are many more tools that you can use with Ballerina. Now let's look at how Ballerina is the deployment of the program that you have developed using unique features of Ballerina. Build command will generate an executable jar file which you can use to run with Bell tool or using the Java JDK version as well. You can also simply do Bell run in your program, which will compile and run your program in your machine. So both of these are supported with Ballerina. Ballerina also support native compilation using graalvm. You can simply say build ---- graalvm, which will compile a machine code according to your machine architecture, which runs on your machine as an executable. You can also build a Docker container using build command, which packs your application to a Docker image. So Ballerina compiler is aware of your application and it will automatically generate Docker file and Docker image for your application. You can simply say build ---- cloud equal Docker, which will generate Docker file and a Docker image for your application. You can also build graalvm compatible Docker image as well. You can simply say build ---- cloud equal Docker and ---- graalvm, which will compile a Docker image into a graalvm. So these are the stats of some popular frameworks and Ballerina in using graalvm. So as you can see, Ballerina pretty much has the same or better experience with compared to these values in other frameworks. Not only that, Ballerina also generate Kubernetes artifacts for you as well. When you just write a service or a main function or anything, you can simply say build ---- cloud equal k-test, which will generate YAMLs that are required to deploy your application in Kubernetes. This also build a Docker image for you as well. And that Docker image will be added to your deployment YAML, and you can just say kubectl apply and give that YAML folder. It will automatically deploy your application into Kubernetes cluster as well. Ballerina also support function as a service. You can write a Ballerina function, either deploy it in Azure Functions or AWS Lambda. There are built-in support for these things. You can simply add annotation, or you can simply write an Azure function executable and generate an Azure function executable to deploy in Azure Functions as well. Well, you can now deploy Ballerina as a jar file, Docker image, graalvm plus Docker, and Kubernetes. Now let's see what we can do with observability in Ballerina. Every Ballerina programming is automatically observable by any telemetry tool. You can view all the visibility and code's behavior and performance automatically will be published in OpenTelemetry syntax, and you can simply add them and view them in any OpenTelemetry supported tool. Distributed login also supported by Ballerina. You can simply say no hub bell run and add this one and redirect your output to a Ballerina log. Or then you can tail this log as well. So you can view these log value outputs in Elasticsearch as well. Alright. So let me explain about my setup a bit here. I'm using vscode with Ballerina extension installed, and my current Ballerina version is Swan Lake Update 7. Let me explain about the scenario a little bit. What I'm going to do is I'm going to write a service, HTTP service, which will provide the location and weather information when you provide an IP address to that one. In order to do that, I am using two API endpoints. One is IP API, the other one is weather API. So this IP API endpoint, what it does is it will return the location data when you provide an IP address for this one. This location data contains latitude and longitude belonging to that IP address. So now I am going to extract those two location data, latitude and longitude, and then pass that one into the weather API endpoint, where I will be passing that latitude and longitude value to get the current weather information for that particular location. Then I am going to combine the results of these two and provide an aggregated weather data update for that particular location, which contains following items. So it contains last updated time of the current weather, temperature, condition, feels like weather information. Then it will also contain the location information, city, country, and the ISP. So I have exposed this one as a service called geo with base pass geo data, which runs on port 99. And I have defined a resource function which does all of this, which accepts IP address as a path parameter and returns the weather data or a bad request or internal server error depending on the results that we receive. Let me show the graphical view of this program real quick. So you can simply click on this icon, which will explore the graphical view, and it will give you a glance of what you have written. Here we have this get your two functions, one service, one record, and three module level variables. So what these functions does is this one get geodata, the other one get weather data, and this service, it contains two resources, and it has to it returns this weather data. And I have used the user key, which is the key for the weather API that I need to invoke. So I am reading this value from the environment variable when we run, and it is configurable in Ballerina. So let's take a look at the service view of this graphical view. You can see the functions that resource functions that I have written here graphically, similar to that OpenAPI spec level visualizer. You can also view the flow code view of this one, which explain the logic that is written inside this resource endpoint. So we have this endpoint which returns which is very clear and easy to understand. If you want to document your code, you can simply copy and paste this value and be done with it. All right, let's try and invoke this service in my local machine. So I'm going to use the terminal for this one. In the terminal, I have created two terminal instances, one to compile and one to invoke this service. I'm going to do a bell run on this folder, which will compile my program and then also run it in this 9090 port. In this terminal, I'm going to use curl to invoke this one and get the output. All right, it's compiling. Let me type the curl real fast until that. We can do HTTP, and it's running on my local machine in port 9090. My base path is geodata, and the weather is the endpoint, and it accepts IP address as a path parameter. Now it is running on port 9090. I can simply invoke this one. As you can see, now you can see the output of this program and the logs that I have added in this program, which prints the location information and the weather information. And finally, you can see the output on this window, which contains the details for my current IP address location. Let me invoke another IP address as well. Let's say 172 here. All right, it's from United Kingdom, and it's heavy raining at the moment. All right, that's one way of testing. Let me show you another way using the graphical view. You can simply click on this try it button, which will invoke the Swagger editor for this API, which contains all the results, server, and the port you can provide. and I can just say get weather IP and try it out and enter an IP address here. Let me say 172.10.20.1 and execute. It will give a nice output in graphical view as well. So United States, partially cloudy, and these are the temperature information. That's the graphical view. I want to just give a glance. You can do a lot more with this graphical view. Now, since we have running this, let's run this one in Kubernetes. So I'm going to do this without writing a single YAML file or building a Docker image. All right, I have stopped the service for now. But before doing that, I want to add another resource to this one to check the readiness of this service. Let's do it by graphical way. I'm going to go to service and going to add the resource. And it will be a get resource, and my path will be health / readiness. Okay. So this is the endpoint that I will invoke in my readiness probe, and the response for that will be 200. Okay. Then I'm going to do it and then save. As you can see, the code for this one got automatically invoked. Now I'm going to do a return HTTP okay here. Okay, now we are ready to deploy this one in Kubernetes. So in order to modify the Kubernetes artifacts generated by compiler, we can use this cloud.toml file. Here I have added a cloud.toml file to configure the name of the Docker image that we are building and the tag that we are providing for that image. Also, as you can remember, we have a configurable variable which requires the user key to operate and pass it to the weather API. So that for that one, I have already created an config map which contains this user key, and I want to use that in my deployment. So I am saying that use this weather info config map and use that key user key in my deployment. Now I want to add the readiness probe to this one. As you can see, we can simply type readiness and it will give you the suggestions. Here I have to give the path. So my path will be health / readiness. It should be geodata health / readiness, and my port will be 9090. Alright, now we have added the readiness probe. Let's compile. So I'm going to use bal build -- cloud equal Kubernetes command, which will compile this program, then pack that jar into a Docker image, and the Docker file will be generated along with the YAML file. Let's see. Alright, we got an error, invalid resource provenance path. Alright, as I said earlier, the compiler is aware of the resources and the YAML files. So we can see that health actually contain an EZ here. So I have missed that one. Let's add it and try again. So let me, until it builds, let me explain about my Kubernetes cluster. I'm using Rancher for desktop along local cluster. So I can use the same Docker registry in my local machine in this Kubernetes cluster as well. Alright, now it's generating executable. Likewise, it generates Kubernetes artifacts that are mentioned here along with the Docker image. So these things should be in there, and it will finally print the commands that you need to run this program. If you go to the target folder and Kubernetes file, you can see that the file is already generated, and it has created a service with port 9090 of cluster IP, then the deployment with the same labels which will match these service labels. And as I mentioned earlier, we have this config value parameter which will read from this one and inject it into the container that we have provided. The name is geodeployment and the port is geoprc1. And it also got that readiness probe configured as well with the initial delay of 30 seconds. We also generate an horizontal autoscale, pod autoscale. If you look at the Docker file, it contains the jars that you require to run this one and the Docker image as well. So now I'm going to do, let me quickly run a Docker images command to show whether the Docker image has been built. I'm going to do Docker images. As you can see, we have this geoweather data v110 just created about a minute ago. Okay, now I'm going to run this command, which we got from this output of this Ballerina 1, kubectl create -f and the path to the YAML file. Okay. All right, everything got created. Let's see the status. Okay, still it is running. I think this is because of that initial delay of 30 seconds we have added. Let's wait for 30 seconds and see. Let's see other resources also got created. Get svc. Sorry. Okay, we got this geo service and get HPA as well. Okay, we got this HPA as well. Okay, still it's not running. Let's check the status. Describe pod. Okay, it's still waiting for that readiness fork. Okay, now it's running. Now we want to expose this service as a node port in our cluster. So I'm going to type the command that we already retrieved from that build output. Expose deployment, your deployment as a node port. Okay, now this will create a node port service which we can use to invoke this service in the Kubernetes cluster. So it's exposing this 9090 via this 32224 cluster. Now let's invoke that one and see whether we get the same result we got from curl. Before doing that, let's log the pods, tail the logs of the pods as well. We are going to do this log. Okay, now we just do a same but with the pod that we got for the node. What's the port? Okay, let me quickly get the port. Okay, it's 32224. I'm going to use that in the curl. Okay, all right, we got the log and the result. Let's try another IP address as well, this time like 112. Okay, we got our local results as well. As you can see, the pods of pod logs are also being printed. Okay, now that's all for the demo that I want to show. This is just a scratch of the surface of what Ballerina can do. In this demo, we have explored Ballerina's network primitives, the dual textual and graphical syntax, and we also experienced the ease of concurrency management and how easy it is to deploy in Kubernetes or Docker environments. The power of Ballerina does not stop here. It's a dynamic language that keeps evolving, and there's always more to discover and leverage in your cloud-native applications. I encourage you to take what you have learned today and apply it in your projects. Furthermore, you can experiment, collaborate, and innovate with Ballerina as you build your scalable, efficient, and resilient cloud-native applications. If you have any questions or would you like to explore Ballerina further, please contact us with one of these channels, these websites I have mentioned in this slide. Thank you once again for joining with us. Have a fantastic day ahead.